this video, I will explain a problem of a outdoor substation. So the question is, draw the line diagram of a pole-mounted outdoor substation, 11 kV for 15 volt, 250 kVA transformer showing all necessary parts. Okay, so draw the line diagram of a pole-mounted outdoor substation, 11 kV for 15, 250 kVA transformer showing all necessary parts. So from this question, we can understand that pole-mounted station means it is an outdoor substation. Okay, and primary side of the transformer is 11 kV and secondary side of the transformer is 415 volt, and capacity of transformer is also given 250 kVA. So you draw the general diagram of outdoor substation. So this is the general diagram of outdoor substation. So in this diagram, the supply is coming from the utility side, that is 11 kV. Then first you install a lightning arrestor, 11 kV lightning arrestor. So the function of the lightning arrestor is to protect the system due to the over voltage of lightning. And the next device is a gang operating switch, that is 11 kV gang operating switch. Then after that you just draw a HG fuse, that is horn gap, or we can also say it is a dropout fuse. Okay, so HG fuse or DO fuse, dropout fuse, that is the voltage rating should be 11 kV. And then you erect a transformer. Okay, erect a delta star transformer of the capacity of 250 kVA. So the capacity is given 250 kVA. So 250 kVA. Then you install a underground cable from the secondary of the transformer, which connect to the main switch bus bar or main bus bar. Okay. Then from the main bus bar, we take different tappings, okay, or different sub-circuits to connect individual loads. So that is the general outline or diagram of a outdoor substation. Now we need to define the circuit breaker as well as fuse and the cable size, everything. So before defining the system, we should calculate the primary current and secondary current of the transformer, rated primary and secondary current of the transformer. So first we are going to calculate the secondary side of the transformer. Okay. So how to calculate the rated current in secondary of the transformer? So we have an equation I, secondary current IP equal to, okay, current in secondary equal to kVA, okay, kVA into 1000, okay, kVA into 1000, you convert into VA, okay, kVA into 1000 divided by root 3, because it is a 3-phase, so divided by root 3 into what is the secondary voltage, 415 into, so into 415, root 3 into 415, okay. So we get the value, 250 is the capacity of transformer into 1000, so the multiplication of 1000 is to convert the kVA into VA. Then root 3, because it is a 3-phase supply, so you root 3, apply the root 3, and you root 3 into secondary voltage is 415. We get a value of 347.79 ampere. So that is the secondary current rating of the transformer, 347.79 ampere. Similarly, you find out the primary current. Okay, primary current equal to the same equation, 250 into 1000 divided by root 3 into what is the primary voltage, 11 kV. So 11 into 10 raised to 3. Now you get 13.12 ampere. So 347.79 ampere is the secondary current, 13.12 is the primary current. And also you can check this value with the data book, MK Giridharan data book. Then you can take the data book and take the table number 31. Okay, 31. In 31, our capacity of transformer is 250 kVA. So the corresponding current is primary current is 13.12. Okay, we got the value 13.12, and corresponding secondary current is 333. Okay, almost 330, 340 range. So 347.79. Okay, then you check this value with the table number 31, and on the same table number 31, you can see that the size of the cable required in secondary side of 250 kVA transformer is in table number 31, the size of cable, that is 400, sorry, not 400, that is 185. Okay, 185 square mm cable. Okay, so from the diagram, so this is the secondary cable. So you can write it is 3.5 core 185 mm square LT cable, 185 mm square LT cable. Okay, and also next we should find out the rating of fuse rating as well as the geo switch. Okay, so from the table number 34 of a data book, MK Giridharan data book, table number 34, you can see that the HT fuse rating, HT means high tension fuse rating. Table number 34, high fuse rating is okay. From table number 34, the HT fuse rating of 250 kVA transformer is 32 ampere. 32 ampere. Okay, 32 ampere. So you can define the fuse 32 ampere 11 kV, and also you define the gang operating switch as 11 kV bar 32 ampere. Okay, and also you should define the secondary fuse rating. This is the secondary fuse, secondary main box. So the current carrying capacity of secondary, that should be above the rated current of secondary of a transformer, 347.79. So from the data book, table number 31, you can see the current is 333 ampere. So you can use the current rating above the 333 or above the 347 ampere. So that's why we put 400 ampere in main switchboard. So this is the diagram for a particular problem, and now you list out the different type of list out the equipment or device used in this design. Okay, so initially, what is the first one? Initially 11 kV lightning arrestor. Okay, 11 kV lightning arrestor is used. So this is the 11 kV lightning arrestor. Second one, a gang operating switch. Gang operating switch, 11 kV, 32 ampere gang operating switch. That is the second element. So you write 11 kV, 32 ampere gang operating switch. What is third one? Third one is HG fuse. Okay, this is the HG fuse or DO fuse. So what is the rating of this HG fuse? 32 ampere, 11 kV. So you write the third element, HG fuse, 11 kV, 32 ampere, HG fuse. Next one, a transformer, 250 kVA, 11 kV, 415 kVA transformer. Then a cable, secondary cable, that is 3.5 core cable, 185 mm square LT cable. Finally, the current rating of LT switch, main LT switch, that is 400 ampere. Thank you.